First, let's review yesterday what we have learned. First, the 5G network architecture and key technology. First, the NSA technology, SA networking. SA networking. SA networking, and compared with our 4G network, the architecture is similar, but the differences is like in our core network. In our 4G we call it EPC, EPC, and EPC, MME, and PGW. PGW, and SGW, and so on, and HSS, and so on. This have dedicated equipment, But for our 4G, the core network, we call it NGC, next generation core. NGC based on the cloud. And all the function, all the network convert, all the network element converts into function, based on the IT infrastructure, and all the function deployed on the server, based on the server. AMF means access and mobility function. This is used for control plane, and the UPF used for means use play function. And compared with the 4G, the 5G core network and complete separation between in control plane and user plane, and the function is more dedicated than our EPCs like MME, like PGW, like SGW, and the function is very flexible, and you can select function that you need to meet a different service to different user. It can utilize the network resource, and it can meet the different users meet the users different requirements. So it's very flexible. It's programmable. And between the GNB and the core network, the interface, the NGC and the NGU. NGC means the control plane. U means the user plane. This is the interface. Actually, it's similar to the S1. 4G, the 4G S1, C and S1, U is similar too. It's similar, and between the G node B, the interface we call it XN, and or 4G call it X2. This is the SA networking. And this is the table show us the relationship between the 5G's and the 4G's core network function. The MME mobility band response AMF, and the user authentication response UAUSF, and the session management SMF. And so on. So we say that for 5G's core network is more dedicated, is more flexible, because it's based on cloud, And for our core network, there are some features like CUPS. CUPS means the control plane and user plane separation. This can improve the user experience and networking efficiency. We can deploy the UPF near the user, near the application, or near the base station. It can it can reduce the times, can reduce the delay, like the V2X. We can reduce the delay. And also, we can also deploy the CDN servers in the aggregation layer. So if you want to visit or download the video, they can visit the CDN directly and don't need go through the IP transmission to the core network. It can serve the bandwidth, can reduce can improve the efficiency. The second is slice. Slice. The ITU in our size means like EMBB, like UILC, like IoT, MMTC. We can depend on the user or customer's requirements, cut the physical network into multiple slicing, multiple slice, like slice 1 for the EMBB. For if we want to broadcast on HD broadcaster, we just need an EMBB service, so we can configure the slice to support the EMBB. I need the big bandwidth. This is a slice. And if like V2X, like the remote control, we need the URLLC. We can cut a slice to meet this requirement. And the function can be programmable, and can meet this kind of service. This is slicing, and the native cloud. Our core network based on the IT infrastructure, and we can install the software very easily. If we want to enhance the capacity, we just insert the disks. If we want to if we want to install some function, we just install the software. It's very easily and flexible. And MEC, mobile edge computing. It can also reduce the delay. And in some factory, the customer don't want their data go through the IP public network, so they will deploy MEC in their own campus. This is one scenario. And another, so for example, like the AR VR, if we want to process the video, process the AR VR videos, we also want delay. We also want to reduce the delay, so we can deploy the MEC server near the application to reduce the delay. This is the core network architecture. And the cloud RAN evolution. DRAN means the distributed radio access. Actually, now all the operator use the DRAN, like a base station. And this is a machine room. In machine room, there are many. There are BPU in the machine room, and this is RRU on the tower. And maybe here. It's RRU. And let's say as a tenant. And in our city, there are many RRU. There are many base stations. RRU. This is a machine loan. Distributed rent. In our city, there are many base stations deployed in the city. This is DRAM. Like also use the IP transmission to the core network. And the CRAN means the centralized radio access network. Maybe we can deploy the BBU in the one equipment room. Like BBU1, BBU1, BBU2, BBU3, or even more. And this BBU are installed in one equipment room, and let's through our optic fiber to the base station, to the RRU. Through optic fiber, optic fiber. For CRAN, one advantage is that they can serve. The operator don't need to rent too much equipment room. In our city, the machine room is very limited. Like this one, this need more machine room to install a BBU, and the rent cost is very expensive. But for this mode, CRAN, it don't need much equipment room. We just need more optic fiber to connect with the RRU. To deploy the base station, and for operator, they may use this mode to deploy this base station. It can reduce the cost. And for Cloud LAN means the CU and the DU separated. CU and the DU centralized unity and distributed unity, and the AAU. Let's see the F1 interface and the CPRI, eCPRI. This mode, CU and DU and AAU. This is the Cloud LAN. Maybe in the future or 5G will use this mode. And the CU will deployed in the server, on the server. And the CU means centralized unity. It can serve our network resource, can share the network resource. And the DU can deploy the near user, like some real-time service. We can deploy the on the DU for UPF, and it's AAU on the tower, and also is very flexible. It can meet the different requirement. This is our DU and CU and cloud DRAM, CRAM, and Cloud RAM. And also we learned the new L interface. This is our large bandwidth. For LTE, just have this bandwidth, and for 5G, the bandwidth is enough. So why why our 5G can support the 10 gigabps? Let's see, there is a C equal to B means bandwidth. The bandwidth is high, so the capacity is high. It can support the high ping rate. And next is the uplink and downlink decoupling. SUL just have introduced because the uplink and downlink frequency imbalance. So the uplink, maybe we use the low frequency band for uplink coverage. This is yesterday we have learned. Okay, let's continue. Let's continue. Let's continue. And the challenges of the millimeter wave deployed. About the millimeter wave is very high frequency. For example, the 28 gigahertz. 28 gigahertz. The high frequency is the more loss there is. Let's compare about the path loss. This is the path loss on C-band. It's path loss on C-band. And this one is the path loss on millimeter wave. This is on millimeter wave, high frequency. Millimeter wave, high frequency band. And they have great differences, like 8 dB. And this one, 8 dB, 18 dB differences are very much loss. So the coverage of millimeter wave will be very weak for 100 meter. And for 3.5 gigahertz, is 103 dB. But for millimeter wave, it's higher. So the path loss is higher. So the millimeter wave will be used for some special scenarios, like hotspot, like used for CPE, WTTH, FWA, or used for the cell back home in some scenarios. It can't be used for the main coverage because only with a very small barrage, the signal will become very weak. So this is a shortcoming of the high frequency band millimeter wave. So it's just suitable, just used for some hotspot. And because it lists the path loss and penetration lost very much. Is penetration lost. You can see that this one is 5 dB, and more is 11 dB. So no matter the path loss or the penetration loss, millimeter wave, the loss is larger, is high. is higher. Only used for some supplementary coverage, not for the main coverage. But for millimeter wave, we have plenty of free resource that are available. It can provide very much broad bandwidth, support very high speed of the throughput. So in hotspot, it will be good supplementary coverage. This is the millimeter wave situation. So high frequency have a large path loss and penetration loss. And for modulation technology, please.
Excuse me, what does NLOS stand for? What's N?
Which one? This one?
LOS. What is the meaning of LOS and NLOS? It's the main line of sight, non-line of sight.
Yes, line of sight. Yes, line of sight. Yes.
Okay, thank you.
Yeah, and the none means none. None of sight. Yes. Okay, next. Second, for modulation technology, quantum modulation. For the modulation in the 5G, new modulation for uplink is introduced. This one. This is for 5G. Another thing, just for uplink, support 256 quants. This modulation is introduced to provide more throughput. The higher order is, the more the throughput is. You can see this this mode. There are QPSK and 16 core and 16.4 cores. 16.4 cores. Like maybe QPSK just means one simple just can carry 1 bit. QPSK may just can 1 bit. 1 bit. And for 16 cores can carry the 4 bit in one simple. For this one, just can carry the 6, and for this one can carry the 8 bit. One simple in one simple. We can see here, and this is 64 quants. It can depend on different phase in one subcarrier to distinguish different user. So for 6 quants, 64 quants, it just can carry the 6 bit. But for 256 quant, it can carry the 8 bit. But for this quants, it's need the signal is good. The signal is good. The signal quality is good. Otherwise, it may cause interference between the two subcarriers. And depend on the QC, depend on the CQI. CQI means the channel quality indicated. Depend on here. depending on this parameter is dynamic. If the signal quality is good, very good, use this one. If the quality is not good, use this one. If the quality is weak, use this one. So you can see it's dynamic. Maybe in the future, maybe the 1028 quants can be supported. This is a quant technology. And next is set about is MIMO. MIMO means the multiple output, large scale antenna array. And this picture shows one principle of beamforming. Multiple antenna can be used for many purposes. Beamforming is one of them. MIMO, we can see, is multiple antenna. Multiple techniques. It can be used for diversity, TX diversity, or RX diversity. And beamforming or special multiplex, multiplex. Actually, we can see this picture, these two antenna, antenna 1 and antenna 2. And the antenna send the signal to the UE, and antenna 2 also send the signal to the UE. When the UE get the two signal here, and the signal in the same phase, for example, like this one. This is antenna 1. Send the signal 1, and this is signal 2. And this two signal is the same phase. It can enhance the signal power, so the UE can get a good signal quality. If the signal 1, like this one, and another antenna send a signal like this one. This is another. This is another signal. The two signal in different phase, and in this point is the pink ring, and this point is value. So this mode may decrease the signal's power. So depend on this. For our massive MIMO, it can adjust the weighting to control the antenna's arrays. They can adjust the antenna's direction. Make sure the UE can get the maximum, can get the good signal. This is the beamforming, beamforming. And for the massive MIMO gain, and you can see the left side is LT 44R, 44R. We have 44, and for 88R. Sorry. HCA. And this MIMO level is much higher. They can get the array gain. Array gain means can increase the number of antennas to achieve the high array gains and improve the coverage. Our 2G or our 4G may have support the 44R, and even our 5G can support 16.4T and 16.4R. So it's good. It's better than 4G. Better 4G. And the performing games. Performing games means it can enable in the horizontal and vertical direction to improve the coverage and the number of users. In our 4G or our 5G massive MIMO support both in horizontal and vertical direction, like in this building. Or 4G just can support the horizontal, like this one, horizontal. Horizontal direction. But for 5G, they can support the vertical direction.
Hi, Trainer. Can I ask a question?
Please.
I can notice that the beams interferes with each other. Is it a problem if a beam interferes with another beam?
No. It's the direction is the direction. You mean these two beams may cause interference? Yes, right?
Yes, that's my question.
Yeah, you mean maybe this B1 and B2 may cause the interference?
Yes.
No cause interference because the B is focused on one direction. Focus on one direction.
Okay. I have another question. Can you know what is the capacity of one beam? Like how much can give bandwidth?
One beam can support how much bandwidth? You mean?
Yes.
Actually, this layer is how to say that? Layer is a finger, the parameter like maximum. 16 data streams are supported. For example, like this one. If the 5G antenna support maximum support 16 data streams, means the signal can provide the signals to the multiple MIMO, multiple user MIMO. Means the multiple user can use the signal at the same times, like 16G B, 16B, 1, 2, 3, 4. This is 1B. Another. This is another. And
each antenna have like a fixed number of beams. Can like provide?
Can you repeat?
Each antenna have like a fixed number, limited number of beams that can provide.
This one, 16.
Oh, 60. Okay.
Yeah. It means actually we call it multiple user MIMO. Multiple user MIMO means can provide the signal, can multiplex the signals at the same time to the different to the multiple user, and the maximum of 16 data streams are support.
Yes. Okay. Thanks, trainer.
Okay, and this is before me, and this is a multiplex games. Okay, support the multiple streams. Support the multiple streams, and can improve the system throughput, and special multiplexing can support more user. So it can improve the capacity, can improve the throughput. The antenna is more, and the more user can be supported. And this is the diversity gain. Diversity gain can make the signal more stable. So for example, this is the UE, and this is antenna, base station antenna. This is antenna, base station, and the antenna can send the signal 1 and the signal 2 to the UE, but these two signals is the same. Send the same data. Send the same data to the UE. It can make the transmission have a good transmission reliability. Improve the data transmission reliability. This is diversity gain. Actually, for the massive MIMO, this technology is very objective, but sometimes if we can see some in our lab, see the video, may help us to understand. Actually, I can see some video may help us understand what's the MIMO. Like this one. This is the video about our MIMO. And we can see this picture. NR massive MIMO. MIMO games broadcasted before me. For traffic channel, the high gain narrow beam can dynamic adjust for the beamforming direction. If the UE here, the base station, the antenna can tracing the UE. If the UE come here, and the narrow beam will follow the UE. If the UE here, the narrow beam will follow the UE, can tracing the UE. This is the channel, traffic channel. It can make sure the UE can have a good signal. And for broadcast channel, and the broadcaster channel based scenarios based B scaling means the broadcaster scaling the UE forever. forever. And at the one time, first time, second time, third time, to scaling the UE, send the broadcast signal like this one, and this is a broadcast channel. This is a B, narrow B, and the narrow B can change the direction from this side to another side, like this one.
Excuse me?
Please.
You have mentioned that the technique of massive MIMO has 64 transceiver and 64 receiver. Is that right?
Sorry, can you speak slowly?
Okay. You have mentioned that massive MIMO technique in 5G have 64T and 64R. Yeah. In this case, the user considered as a receiver. So how can implement 64 antenna in a mobile?
You mean our 5G's antenna support 16.4T, 16.4R. You want to know which T, how many T, how many the beams are used in one UE?
No, how many antenna in the mobile? Because the mobile consider the receiver side.
2T, 4R. Can you hear? 2T, 4R in UE. Right?
Okay.
UE or UE support 2T4, but for our base station just can support 16.4T, 16.4. And now the maximum, the antenna supported in UE just can support 2T4.
Okay, thank you.
Okay. Okay, let's have a short break.